So I'm Scot Breitenfeld from the HDF group, and I've been working on subfiling together with Jordan Henderson on the HDF group. And so I'm going to present an update on subfiling. So before I start, I want to just discuss why you want to use data aggregation, which is what subfiling is. Some of the benefits usually seen on large node counts is that you can make better use of the subsystems that might be on the architecture of the new parallel HPC systems, such as no local storage. So by leveraging these subsystems, you can mitigate some of the locking potentials you might see with a single shared file. And I guess recently at OLCF, the user meeting that the audio gave, Norbert kind of mentioned that probably the maximum you're ever going to see on using a single shared file is maybe 150 gigabytes per second. On Summit, I've got around 300 gigabytes per second, but at some point there's probably limits to how on the bandwidth of how fast you can go with just using a single shared file. And it also reduces the complexity if you're doing a file per process. You won't have that issue. Some of the challenges, though, even though you do have, for example, one node or one file per node, that's still maybe a lot of files to work with when you get into 4,000, 8,000 node counts. And you're doing that for every time step or every other time step. So that might still result in a very large number of files that you just don't want to deal with. So in that case, you either have the option of fusing those files back together, which can be expensive in and of itself, and then moving that large file. Another thing is whether if you want to keep it in the subfile, you want to just transfer those subfiles to wherever you're going to visualize it. And does the visualization package understand what the subfiling is in this case? So you have to be aware of that as well. And then finally, it's hard to say when data aggregation pays off. If you have low number of node counts, then usually you may have overhead that negates any benefit you'd have from aggregating the data. So just a quick recap for those people who aren't as familiar with HDF5. So you have the virtual file drivers, which we've mentioned a lot during these talks. And it's basically a way to map between the address space and the underlying storage. So some popular examples are, of course, the sec2 file driver, which uses a POSIX.io, the core file driver, which you can write directly to memory, and then you have an option of persisting that to disk. You have the MPIO driver, which you can use for parallel I/O, and then we have a whole bunch of other lists that you can find on our documentation page in the reference manual. And you usually set these by just setting a file access property. And I'll show you how that's done for the subfiling. And in the greater scheme of things, when you look at the overall architecture of the library, you can see that at the top you have the HDF5 application, you have the HDF5 APIs, you have the vol layer, and under that you have the native vol, and you have the VFD layer, which is the virtual file driver layer, and of course you have the ones I mentioned, and then you have the subfiling, which I'll talk about. Subfiling VFD. The availability, this was introduced as part of these projects in 1.14.0. It must be built with, when you have parallel support when you're building HDF5, and you must enable it when you build it. It's not on by default. One of the reasons that it's not is because it requires BC11 capable compiler.
No, it doesn't.
But it doesn't now. Okay, Quincy is correct. That's not required anymore, so maybe we can do it default. In terms of an application, if you're already using MPI init, you have to switch over to using MPI init thread, and that requires and at the level of MPI thread multiple, that must be supported in your system. There's other details about subfiling. I've included we have a user's guide at the top to go over subfiling per se, how to use it. But just a general what it is, it's a MPI-based parallel file driver that distributes a collection of subfiles of equal size in segmented strips. You can kind of think of it as a RAID 0 striping. So you have, for example, you have two ranks there. It would write it'd write the HDF5 file, it'd split it between the block 1 and block 2, and then it'd go back to block 3, block 4, and it kind of round robin. That's the default currently. And the default size of these blocks now would be just 32 megabytes. And you can configure that to be different if you choose to do so. So subfiling is basically a compromise between a file per process way and a single shared file, which ticks all the boxes that I mentioned of why you do data aggregation. You want to do the minimizing, locking issues. You want to avoid the complexity of having so many files. And of course, you want it to be able to be very flexible and configurable. And subfiling does that. You just have to change a few things in your code to get it to work. What subfiling does is it uses the subfiling file driver uses an IO concentrator, so which is basically just a file driver that could have each MPI rank. So if which is at a pointer, if at the top you have a rank for each on each node, then you have they all call the HDF5 API. Then you have the virtual file driver. You have the subfile. The subfiling BFD, and then that subfiling BFD calls the IO concentrator, which basically collects all the IO from all the other ranks on that node, and then coordinates with the subfiles to stripe it over all the disks, and then that writes it out using the POSIX calls. And this is what John alluded to yesterday, that if you can swap out the IO concentrator for something, for example, if you're doing encryption, you can swap that out and then use that instead. But as it currently stands, we only have available one IO concentrator to use with the subfiling. So when you use subfiling, you get multiple output files. So the first one is a sub file. This is just a kind of a placeholder. It appears as a normal HDF5 file. We added it has superblock information, and this is useful, for example, if you have netcdf or for example, or CGNS, where they might read the first bytes of the file to determine what kind of file it is. That's very popular using the reading the magic number to determine what kind of type of file it is. And then we use the inode of that subfile to generate unique file names for the other two files at subfiling configure file and the subfiles themselves. So you have the configuration file that also gets written out. So it basically details the subfiling parameters that we use to create the subfiles. And you can validate, it's used to validate what you actually did subfiling and then once you access that out. And it's also useful for external tools to use. I'll discuss one later. But essentially, if you don't want to open up the HDF5 library and then run all that, you can just look at what's in the config files to be able to read those subfiles. So an example of what is contained in that configure file, so you have this